What is pipeline design? It is the procedure by which the designer, taking into account the requirements of the installation, proceeds to the dimensioning of the shapes and parts of the air conditioning distribution system, to guarantee that each area is perfectly heated. What is the design procedure for a duct distribution for air conditioning? The design procedure will depend on the type of installation. In this video, we are going to carry out the steps to develop for a small air conditioning distribution. We will take the following data as a reference. 1. An internal air velocity within all ducts of 2000 feet per minute. 2. An airflow of 400 cubic feet per minute for each ton of refrigeration required by the installation. 3. The fan has enough pressure to get the air to all points. This assumption is based on working with distances closer to 24 feet between the fan and the furthest air outlet. What knowledge does the designer need to understand the procedure that we are going to develop? The first concept that needs to be handled, not only by the designer, but also by the technician who is dedicated to servicing this equipment, is that the area of a duct will always be obtained by dividing the airflow that passes through it by the airspeed within it. Thus, for example, for a flow of 1 refrigeration ton with a speed of 2000 feet per minute, we have required duct area is equal to the flow rate in CFM or cubic feet per minute divided by the air velocity in feet per minute. Remember that for each ton we are going to need 400 CFM of air. So we'd have to divide 400 CFM by 2000 cubic feet per minute to get a duct area of 0.2 square feet. Knowing the area, we can begin to size each duct. If we start to make the design from a rectangular area for the entire system, we can say that the area is equal to the multiplication of width by length. We don't actually know any of these dimensions, but we can get an idea of, for example, the length. We must carry out an analysis in the field or of the plans of the premises, in order to know what is the distance between ceilings that we can use. With this information, we can find the length of the cross-sectional area of each duct. If we consider that the rectangular area is equal to multiplying the length by the width, and taking into account that we have already calculated the area A, and we can know the length, or the height between ceilings. To do this, we must know that the width of the duct results from dividing the area by that height or maximum length. Let's assume that in this case there is a maximum length of the duct area, or distance between ceilings of 0.7 feet. The width results from dividing, for example, the 0.2 square feet calculated above, by the maximum height of 0.7 feet, resulting in a value for the width of approximately 0.29 feet. So the rectangular area should be 0.7 feet long by 0.29 feet wide. With this area value, we guarantee a velocity of 2000 feet per minute within that duct. So, what are the steps to follow for the design of air conditioning duct systems? Since the facility we are going to design is small, less than 24 feet long, we are going to perform the following steps. Step 1. Calculate the thermal load of each room. Step 2. Calculate the cross-sectional area of each duct. Step 3. Calculate the dimensions of the cross-sectional areas, found in Step 2. Let's go with step number 1 for the design of this duct system. We must know the thermal load of each room, in order to select the air conditioning unit that we need. To do this, we go through each room evaluating the length and width. For example, room 1 measures 6 meters long by 5 meters wide for an area of 30 square meters. Therefore, it corresponds to a thermal load of 24,000 meters per hour or 2 tons of refrigeration. The other rooms have dimensions of 3 meters wide by 5 meters long, obtaining an area of 15 square meters, for a thermal load of 12,000 BTU per hour or 1 refrigeration ton. Adding the thermal loads of each location, there is a total of 6 tons of refrigeration. With this value, we select the air conditioning unit, which we are going to use in the installation. Let's go with step number 2 for the design of this duct system. We must know the airflow of each room. Let's remember that room number 1 needs a refrigeration capacity of 2 tons. Now for every ton of refrigeration we must send 400 cfm cubic feet of air. This means that this room needs an airflow of 800 cfm. That value results from multiplying 400 cfm by the 2 tons of refrigeration. The next room, number 2, has a heat load of 1 cooling ton, so it requires an airflow of 400 cfm. Analyzing then this branch of the system, it requires an airflow of 1200 cfm. This value of 1200 results from adding 800 plus 400 cfm, including room 1 and 2. For the other branch, there are 3 rooms, 1 refrigeration ton each. Therefore, 3 tons of refrigeration are needed, which multiplying by 400 cfm, gives us a value of 1200 cfm. The total amount of air required will be 2400 cfm including both branches. Let's go with step number 2. Since we already have all the flows, we are going to obtain the cross-sectional areas at all points. We already know that each branch initially handles an airflow of 1200 cfm. Therefore, to obtain the area A at the air conditioning outlet, we are going to divide 1200 cfm by the recommended velocity of 2000 feet per minute. From there it is obtained that the cross-sectional area is worth 0.6 square feet. The part of the duct, which goes to room number 2, handles 2 tons of refrigeration. Thus, for this duct, we have a flow rate of 800 cfm. Dividing this flow by the recommended velocity of 2000 feet per minute, you get an area of 0.4 square feet for that duct. For the branches, which handle only 1 refrigeration ton, there is a flow of 400 cfm. Dividing this flow rate by the recommended velocity of 2000 feet per minute gives an area of 0.2 square feet. Let's go to step number 3. Each duct needs to be sized. To do this we are going to divide each area by the distance between roofs. In this installation we are going to assume a height of 0.7 feet between ceilings. To calculate the dimensions at the air outlet, the part that handles 1200 cfm must be divided by the area by the maximum distance. So you have 0.6 square feet divided by 0.7 feet resulting in a width for the duct of approximately 0.86 feet. To size the remaining ducts, the corresponding area must be divided by the height between ceilings. Thus, for the duct that handles 2 tons of refrigeration, 0.4 square feet of area A must be divided by 0.7 feet of the distance between ceilings, resulting in a width of approximately 0.6 feet. Similarly, for the duct that handles 1 ton of refrigeration, 0.2 square feet of area A must be divided by 0.7 feet of the distance between ceilings, resulting in a width of approximately 0.3 feet. Thank you for being with us. See you in episode 2 of our series, Ducted Air Conditioning. Remember to subscribe to our channel.